All right, here's a good question. Cylinder, 38.5 diameter. So I have to cut that in half. 19.25, I think, is the radius. Then they say a linear speed is going 128 meters per minute, so that's V. And they want to know angular speed, so I've got to solve for W. So W is equal to V over R, perfect. So here, I would say it's 128 meters per minute. And then I have to divide that by the radius, which is 19.25 centimeters. Then, like you did here, let's convert the centimeters to meters. Then these will cancel. So when I do this division, let me do it quick. Get my calculator. Come on, calculator. Decimals. So 128 times by 100 divided by 19.25. And that equals 664.93 radians per minute. So that's where that radian unit just sort of comes up. And the answer to any question where you're solving for angular velocity is always radians per given time. So that's what the rotation is in radians. And now I need to convert it. So 664.93 rads per minute. And I have to convert it to revolutions. Let's do that first. Oh, you converted the minutes to hours. We can do that. So notice here, because I have minutes on the bottom, I have to put 60 on the top for 1 hour. So the minutes cancel. So I'll take the number that I had and times it by 60. So I get 39,896 radians in an hour. Now we'll do the last conversion, which you've done right here. 39,896 radians per hour. And I'm going to multiply 2 pi rads on the bottom and 1 rev on the top. So if I divide my answer that I got there, divide it by 2 pi, I come up with 6349.66. They want it to the nearest tenth, so 6349.7 revolutions per hour. Okay, so doing everything right, just this, that there was incorrect because it's 672.2 rads per minute. And so these would have to be switched. Good.